This is the geometry video for 6.6 trapezoids and kites. The objective here is to verify and use properties of trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So here you can see here that we have one pair of parallel sides, the other ones are not. That makes it a trapezoid. An isosceles trapezoid is a trapezoid with legs that are congruent. So here, again, the two sides that are parallel are called the bases, and then the other two sides that are not parallel are called the legs. And so an isosceles trapezoid is going to be a trapezoid where the two legs are congruent. And within that, we have a theory about isosceles trapezoids, that if the quadrilateral is an isosceles trapezoid, then the base angles are congruent. So again, I didn't name that here. The base angles here are, these two are base angles and these two are base angles. So if the isosceles trapezoid, all the base angles are, or each pair of base angles are congruent. So in this case, right, these bottom two are congruent and these top two are congruent if it's an isosceles trapezoid. So let's use this in a problem. We can see here we have a isosceles trapezoid, C, D, E, F, and the measure of angle C is 65. What are the other measures of the trapezoid? So since this is an isosceles trapezoid, we know that these two angles are congruent, and this has to also be 65 degrees. We also know since these angles are, sides are parallel, right, these two angles here are same side interior angles, right? If this is the transversal, these are two lines parallel. So these two, since these are parallel, have to add up to 180. So then if you just do 180 minus 65, you get 115. Right, that makes 20 plus 6, yeah. So this is 115 degrees, and then since the base angles are congruent, this is also 115. So measure of angle D is 115, measure of angle E is 115, and the measure of angle F is 65. Okay, so that's how those work. So let's have you try one on your own. In this diagram, the trapezoid PQRS is an isosceles trapezoid. Measure of angle R is 106 degrees. What are the measures of angle PQ and S? So push pause, try this on your own, and then check back for your solution. Okay, hopefully you got that. Measure of angle P and Q are both 74 if you subtracted 106 from 180. And then that means measure of angle S is also 106. And you can see here, right, these are the two sides that are parallel, and these are the two legs that are congruent. So these two base angles are congruent, and then these two base angles are congruent. So it's flipped over, but it still works the same. Okay, so let's move on to problem 2. Here's a picture of a paper fan. The second ring of a paper fan shown at the right consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? So if you look closely, they're talking about these trapezoids here. 1, 2, 3, right? And it says here that this is okay, so this here is saying this is measure of angle. This is called angle 1. So the measure of that angle, right, if this is a circle and there are 20 of these, is going to be 360 divided by 20. So the measure of angle 1 is going to be 360 degrees divided by 20, which is just 18 degrees. So this here is an isosceles triangle with the vertex angle as 18. Which means, right, if these two are congruent, then these two have to be congruent. They have to add up to 180. So 180 minus 18 is 162. And then that means the two angles there are 162. So then that divides to 81. Okay, so these are both 81. So we have here a trapezoid, right, where this is 81, this is 81, and then that's 18, and then so this angle here is going to be 180 minus 81, which is 99, right? If that's 99, that one also has to be 99. And since these two have to add up to 180, then this is also 81. All right, so that is the, so what are the measures of the base angles of this trapezoid? We're looking for y is, and x. So my measure of angle y is 99, and measure of angle x is 81. Okay, so try this next one on your own. It says a fan like the one in problem 2 has 15 angles meeting at the center. What are the measures of the base angles of the trapezoid in its second ring? So now instead of 20 of them, there's now 15. So try this again on your own and see if you can figure that out. Press pause, check back for the answer. Okay, hopefully you got 78 degrees and 102 degrees. When you subtract 20, when you take 360 divided by 15, you get 24. That means the vertex angle of this triangle is 24 degrees. If you subtract that from 180, you get 156, and divide that in 2. That means these two are 78, which means these two are also 78 since these are parallel, and subtract that from 180 and you get 102. Okay, we have some more theorems about trapezoids. The first one is if the quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So that is a property of isosceles trapezoids. You can see here, if you had an isosceles trapezoid, AC is going to be congruent to BD. And then we have another theorem that talks about the midsegment of a trapezoid. So if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is the average of the lengths of the bases. So here is a midsegment right here. It's the midpoint of one leg, midpoint of another leg, and they're connected. This is going to be parallel to the bases. And then the length of this midsegment is going to be the average of these two bases. So let's look at that in a problem. Okay, problem 3 says QR is the midsegment of this trapezoid. What is X? And so we know that since it's a midsegment, this is going to be the average of these two. So if we take the average, right, 4x minus 10 and 8, right, the average is going to be you add the two together and divide by 2. That's going to equal x plus 2. So to solve these, the best thing to do is to get rid of this divide by 2 thing first by multiplying by 2. So double the midsegment, and that's going to equal the average, the sum of the other two legs. So these cancel, and this becomes 4x minus 10 plus 8 equals 2x plus 4. We can separate our two sides. We can combine these to be negative 2. So this is 4x minus 2 equals 2x plus 4. And then subtract 2x from both sides. We're left with 2x minus 2 equals 4. And then add 2 to both sides. 2x equals 6. And then divide by 2. So x equals 3. Okay, so you need to remember that the midsegment of a trapezoid is going to be, this length is going to be the average of the other two legs. So try that in this example here on your own. Press pause and then see if you can figure it out yourself, and then check back for the answer. Okay, hopefully you got 23, and I hope you noticed that this question here is asking for mn as well as x, and this was just asking for x. So here we had to find x, so x was 6. When you take the average, right, 10 plus 8x minus 12 divided by 2 equals this 2x plus 11, and then solve. X is 6, and then when you plug 6 in for x for mn, you get 23. Okay, and now last page, we're going to talk about a kite. So a kite is also quadrilateral. It's going to have two pairs of consecutive sides that are congruent and no opposite sides congruent. So you can see here in this picture, right, two consecutive means next to. So two pairs of consecutive sides that are congruent. So the two that are next to each other are congruent, and then the other two are also congruent to each other, but they're not congruent, the opposite ones are not congruent, right? Otherwise it'd be a parallelogram. And so this here's a theorem that's related to kites. If the quadrilateral is a kite, then its diagonals are perpendicular. So in a kite, it has the property that if you connect the diagonal, if you draw both diagonals, they're going to be perpendicular. So it's going to be a 90-degree angle. So let's see a problem with that one. In this example, we have this quadrilateral is a kite. What are the measures of 1, 2, and 3? So once you know it's a kite, you know this is going to be 90. So the measure of angle 1 equals 90 from the theorem we just learned above. You also know in a kite, right, this diagonal, since these two are congruent, these, actually I think I might have missed talking about something here. Also in a kite, what happens is this diagonal here is a line of symmetry, so everything around it, if you fold it, it's all going to be symmetric. So these two angles are congruent, these two angles are congruent, these two angles are congruent, and these two angles are congruent. So that's also what's going on in the kite. And then obviously what we just learned above, that these are all 90. So here, since this is 52, then measure of angle 3 also has to be 52. And then since this is a triangle, right, this is 90, these two have to add up to 90. And since this is 52, you can just take 52 away from 90. And you get 38. So the measure of angle 2 equals 38. So you use triangle symmetry, these being 90, and then and triangles equaling 180 to figure these out with kites. Okay, so try this next one on your own. Press pause, and then check back for the solution. Okay, and you can see here we got measure of angle 1 is 90. These two have to be the same, so measure of 3 is 36, and then since this is a triangle, this is 90. These two have to add a 90. 90 minus 36 is 54. Okay, and there's the lesson.